Hello and welcome to Cloud Tech 10 for the 22nd of January 2018. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. Accelerated networking for Azure virtual machines is now generally available. Without accelerated networking, all traffic in and out of a virtual machine travels via the host machine and a virtual switch, which applies the appropriate rules and policies. With accelerated networking, this processing is moved to the networking hardware, which bypasses the host and the virtual switch. To use accelerated networking, the feature must be enabled when the network interface card for a virtual machine is created. Let's create a new Linux virtual machine with accelerated networking enabled using the Azure Cloud Shell and the Azure CLI. I'll create a new virtual network and a subnet by specifying the resource group where the virtual network will reside, the name of the virtual network, the IP address range, and the details for a new subnet and the subnet address range. Next, we'll need a network security group, which is created by specifying the resource group and a name for the security group. Now we'll add a rule to the network security group to allow us to connect via SSH. So I provide a resource group name and the name of the network security group. I'll give the rule a name and define a rule that allows access via the TCP protocol inbound, give the rule a priority order, and we want to allow anything coming from the internet to connect to the SSH port 22. We'll need a public IP address so we can access the virtual machine, so let's quickly create one. Now here's the critical part. We'll create a network interface card by providing a resource group, a name for the interface, specifying which virtual network and subnet we will connect to. And this all important line here enables accelerated networking for this interface. We'll specify the public IP address and network security group to be used, and then wait for the interface to be created. Finally, we'll create a virtual machine and attach it to the accelerated network interface. So we'll provide the resource group, the virtual machine name, we'll use the Ubuntu long-term support image, choose the size of virtual machine we want to deploy, give the credentials for the administrator account and the network interface that we're connecting to. After a couple of minutes, the virtual machine has been created. I'll make a note of the public IP address that's been assigned, and then we can connect to the virtual machine over SSH. If I run the lspci command, I can see at the bottom here the Mellanox Technologies device, which is the accelerated network interface. And using a command like this, I can verify that there is activity on the device and that accelerated networking is in use and working properly. The Azure Cloud Shell has been generally available since late 2017 for the Bash version of the shell and is in preview for the PowerShell version of the shell. The Azure Cloud Shell provides convenient access to command line tools for managing your Azure resources and also comes with tools for working with products such as Kubernetes or Terraform. The usual way of accessing the Azure Cloud Shell is by clicking this icon here at the top of the Azure portal, which will then open a Cloud Shell session at the bottom of the portal. However, there are other ways to access the shell. From a browser, you can go to shell.azure.com to get instant access to a Cloud Shell instance. Or if you want to specifically choose a Bash or PowerShell shell, then use the specific URLs shell.azure.com/bash or shell.azure.com/PowerShell. If you're a Visual Studio Code user, install the Azure account extension. Once that's done, you'll gain two new options to open Bash or PowerShell in Cloud Shell. Then you'll get Cloud Shell access directly within Visual Studio Code in the integrated terminal. Or you can enhance your web pages, such as documentation or blog posts, by embedding the Cloud Shell. From this URL, you can get the code needed to add this Launch Cloud Shell button to any web page. App Service Diagnostics was launched in November 2017, providing a bot-based service that you can interact with to get help diagnosing problems with your web application. The service is being continually improved and more new features have been added. You'll now see that an option for TCP connections has been added. From here, you can get to analysis of TCP connections and view a summary of the past 24 hours and information on port rejections and open socket handles. Linux app services are now supported, initially offering web app down, web app slow, and container initialization. And for .NET applications, you can now get straight to application insights from the diagnostic tool. Service tags for network security groups are now generally available. Service tags help minimize complexity when creating network security rules and are used in place of an IP address or range of IP addresses. When adding a new security rule, change the source to service tag, then in the source service tag box, you'll see the options that are currently available. Internet covers addresses outside of your virtual networks that are publicly accessible over the internet, including Azure services with public endpoints. Virtual network includes all address ranges for your virtual networks, including connected on-premises address ranges, peered virtual networks, and virtual networks connected via a virtual network gateway. Azure Load Balancer is for Azure's infrastructure load balancers. Azure Traffic Manager is the public IP address space for the Azure Traffic Manager service. Storage represents the address space for Azure's storage services. You can either choose the storage option to select all of Azure storage, or you can drill down to a specific region. And SQL is for Azure SQL Database and Azure SQL Data Warehouse. And again, you can select specific regions if required. Azure Data Factory V2's Visual Tools have now been enabled in public preview. The Visual Tools allow you to get pipelines up and running quickly without writing any code. Here's an example of setting up simple pipelines that will copy files in Azure Blob Storage using the Visual Tools. In Azure Data Factory, click the Author and Monitor button here to go to the Visual Tools. Next, click on this icon to go to the editor. First, we need to set up a connection to an Azure Blob Storage account. So I click on Connections, then New, and then find and select Azure Blob Storage. I'll give this connection a name and then pick the storage account that I want to use. I'll click this Test Connection button here to make sure that everything is fine with the connection to the storage account and then click Save. Next, I need to add a new dataset. So let's click on this Add button, then Dataset, and then choose Azure Blob Storage. I'll call this dataset Input Dataset and then under the connection option, I can choose the linked storage account that we previously set up, and then browse to find the file that I want to use as my input data. I can click the preview data link here to verify that the data is what I'm expecting. As you can see, this is a very simple file. Now I'll add a second dataset, which will be the output. So again, I click the add button, then dataset, and then Azure Blob Storage. I'll name this output dataset, and then under connection, again, choose the linked storage account, and this time I'll manually specify the location and name of the output file. I'm using this text here to specify that I want a new name auto-generated each time. And now let's configure a pipeline. So click the add button and then pipeline. I'll name this copy pipeline and then choose data flow, and then drag the copy activity over to here. Let's name this copy from blob to blob. Then I can specify the source as being my input dataset and my sink as being the output dataset. I'll click the validate link and I get a message telling me that my pipeline has been validated and no errors were found. Let's see if this is working by clicking the test run button. At the bottom here, I'll see the progress and eventually see that the pipeline has completed successfully. And if I go to my Azure Blob Storage, I can see that there's now a new file in my output folder. To start using the pipeline, I first need to publish it to the data factory using this button here. Once that's complete, I can now initiate my pipeline using a trigger. So I'll click trigger and then trigger now. To see progress, I'll need to switch to my monitor view by clicking here, and I'll see that my manually triggered pipeline run has completed already. I can drill down to get more details on the pipeline run and can see that one file has been written as output. If I go back to my blob storage and refresh, I can see that there are now 2 output files. Finally, let's set this up to run on a schedule. Under trigger, this time I choose the new edit option and then choose to create a new trigger. By default, this will now run every minute forever until I take action to stop it. Let's define an end time so that this trigger only runs every minute for the next 10 minutes. Click the activated box here and then next. Back to the monitor, and after a short while, the first scheduled trigger begins. You can see in the monitor that this is listed as a scheduled trigger rather than a manual trigger. And over the next few minutes, we'll see more of these running. And back in my storage account, I can now see new files being created as the result of the triggered pipeline runs. Azure Monitor has a new alert monitoring view currently available in preview. By clicking the alerts preview item in Azure Monitor, you will see this new interface that shows a summary of fired alerts and total alert rules along with details of any fired alerts. You can also view all the alert rules currently applied, and you can create new rules for any subscription or resource from here. The select resource link lets you select a specific subscription. View and select the resource types deployed there, choose a specific resource, and then define the details of the alert that you want to create. You can then see details of all alert rules defined across all of your subscriptions in one place. Azure Security Center now supports custom security assessments. By default, Azure Security Center monitors over 150 recommended rules that it uses to generate security recommendations across the Windows and Linux operating systems. With custom security assessments, you can configure these rules to suit your own requirements, or add additional rules. From Azure Security Center, choose Security Policy, then select your subscription, and then edit security configurations. Click the download file button and you'll get a JSON format file downloaded that contains all of your current rules. You can then open them in an editor such as Visual Studio Code to find and modify existing rules or add new ones. When finished, simply return to the Azure portal and upload the file back to Security Center. Full documentation to help you understand the structure and content of the configuration file can be found at this URL.